Hello everyone. So today we'll be going to cover another question related to 2D from 1D. Okay. Without wasting time, let me just paste the question over here. So the question says that we are given a 2D matrix with some dimensions r cross c. So there are r rows and c columns. This is the question just to give you an idea of when to use 2D from 1D, this type of problems, when to use this type of templates, which we have learned in the last video. And I've put that video in our prefix sum playlist, so you can go through that first. We will get the better idea of when to use what and all the templates and all those things. And then you can come to this question. This will be a very short video. And the question says we need to find the maximum possible sum of any submatrix within that given matrix. Okay, so the question says that we are given a 2D matrix and we need to find the maximum possible sum of any submatrix. Now, this question says maximum possible sum of any array. The first step is to convert it to the 1D array. So, maximum possible sum of any subarray or maximum possible sum of any subarray. So we are redirecting it to maximum sum subarray. Now what is this? This will give us a clear idea of we need to use the cadence algorithm because we need to find the maximum sum subarray. There is no fixed condition on k given. Okay, so anyways we need to use this, and also in the constraints the elements of this 2D matrix could be negatives and positives both. So of course, it's clear from this that we have to use the cadence algorithm. So I'll just mention the steps over here and then we can move to the code to write it. So our first step is to what? Write cadence algorithm to find maximum sum subarray. Okay, this is for 1D. Our second step is to run those three loops of I, j, and k and make all possible 1Ds from 2Ds. Mean. Okay, and the is to third step is to get the answer for each possible 1D and compare it to get the maximum answer. So these are the three steps. Okay, we have to do. These are the three steps which I've mentioned in very detail in the previous video. So if you have not watched it, I will strongly suggest you to go to that video and you will learn this. Okay, so this is the GFG based question. So without wasting time, let's just move to the question. Okay, so the question says the same thing. We are given this matrix 1, 2, minus 1, something like this. And the answer says that if we choose this submatrix, okay, minus 3, 4, 2, 8, 10, 1, minus 1, 1, 7, then we will get the maximum answer. So when can this be possible? Whenever I is 1, when we are starting from this row only, when we are starting from this row, so whenever I is 1, okay, we'll go until j is equal to 3. 0, 1, 2, 3. We'll take all the rows, so it will be minus 8 plus 3 and minus 4. So minus 9 at this point, and then minus 3 minus 1 minus 4 and 8. So 4 will be at this point. 4 plus 10 14 plus 1 15 will be at this point. 7 and 1 8 9 10 will be at this point, and minus 6 plus 3 minus 3 plus 1 minus 2 will be at this point. And then if we take the maximum sum sub array, we will be going to know that if we take this column, first column, second and column, third as one subarray, then we'll get the maximum answer. So basically what is this? This is referring to as I as 1 starting from the first row, j as 3 going until j is equal to 3, so adding all these three rows, and then columns from 1 to 3. 1 to 3. I hope you got my point. Okay, so let's just write the code first for cadence algorithm. So our cadence algorithm will pass nothing but a single array. We will have its size and we want the answer to be maximum. Okay, now we don't want the submatrix to be empty, right? Of course, we need to find the maximum possible sum of any submatrix within the given matrix only. Within the given matrix only. So our this thing couldn't be the empty submatrix. Okay, so we'll assign our maximum to be as minimum as possible. Okay, and we can go for int I0, I less than n, I plus plus. I will have one sum also for sure. Okay, we will be doing sum plus equal to array of I Before checking, we will assign it max is equal to max of maxi comma sum. And now we will check if sum is less than 0, we'll make it 0. So this is our second template. Okay. And we will return our maxi. Fine. So we will have number of rows over here and number of columns. Okay. Our 3-step basic. So we'll first initialize our maxi also as not 0 but minus 29 only in this case also. So we'll have one to start from which I. Okay. And then for each starting I, we will have one row vector or array vector of size columns, total number of columns. Now we will start from that row, we'll go until the end row, and we'll start from 0 to m columns. What we can do is array of k. We will add this matrix of j comma k. Cool. After coming out of this k loop, we will try for each possible array this maximum. So maxi comma this Kadane algorithm. It will go for each of this array. Cool. Let's return it. Let's try to see and return it. Okay. So this is how it became very easy for 2D from 1D type of cases. Okay, I hope you got this type of questions. This could be for sliding window also. This could be for prefix sum with map, which we have done before. This could be for Kaden's algorithm. It could apply to any of these 3 sub-array related algorithms which we have learned until now. Okay, my next playlist will be coming up on the binary search. So stay tuned for that. Do like, share, and subscribe, and share it with your friends if you have learned a lot out of these 3 playlists. But these are again interdependent on each others. And do watch the differentiation video on these 3 algorithms, when to choose what, so that you can get it solved easily. Stay tuned, stay safe. Bye bye.